I'm trying to introduce you to BACnet Secure Connect and telling you how we can get older, already existing systems into the system. I'm working for Contemporary Controls. I am the application engineer for the past 12 years in our Leipzig area. And what are we doing? Contemporary Controls is a company being around for almost 50 years now, producing all kinds of networking equipment and building automation equipment as well, especially based on BACnet. So we are the bus guys when it comes down to MSTP and BACnet IP. BACnet SC. Let's get right to the bone. BACnet always had one problem. It's an older standard right now from what we are looking at right now. It's about 30 years old, and back then nobody was actually expecting a building being connected to the internet. So we've been using UDP, unencrypted communication, broadcast messages to get all clients somehow connected, and we thereby built an inherently insecurity and made it a bit difficult to get any messages through subnetting. So we introduced BBMD to it. BACnet Secure Connect is now the approach to finally bring some security into the protocol. So we basically try to get around all those disadvantages by adding security and replacing BBMD and the non-directed messages. Let's remember how BACnet IP was working, or how it's working right now. So we got all that nice network. We got probably not known network to us, third-party network even. We have BACnet IP devices that are pretty much allowed to talk at any time to anybody, sending out UDP messages that are not encrypted. Any MSTP devices further introduce the BACnet routers to actually get around the physical layer and having a serial connection connected to a BACnet IP network. It is a bit more secure, but still not properly encrypted. The whole communication, especially the teach-in and learn-in procedure, is done via broadcast messages, so anybody could potentially hear what you are actually shouting out there into the network. And we do not want that anymore. BACnet Secure Connect is now adding a new data link layer to the standard, and it's basically just an addendum. We're going to talk about it in a few years, basically like we are talking about MSTP and BACnet IP right now. As means of security, we introduced TLS 1.3 as the state-of-the-art encryption as it is right now. You never know when the next data breach is going to happen, so better keep it low on the TLS version right now. Furthermore, the communication is a bit restructured. We're going to introduce a more managed approach to how we are doing communication between clients. So we found a way to get around the use of broadcast messages and finally made it a directed message between clients. Talking about security, just a real quick introduction. TLS 1.3 is, as mentioned, the currently state-of-the-art encryption method, and we're using WebSockets to actually establish the communication between clients in BACnet SC. How it's actually working. Let's remember, BACnet SC is using tokens. It's just throwing out there introduction to may I talk. It gets the token back and sending out the message. So it's basically just a back and forth between the clients on an MSTP network. The BACnet IP is shouting out. Nobody really cares. Nobody really manages anything. And the UDP message at some point reaches its final goal. BACnet SC instead now introduces hubs and nodes. So we introduce a central hub to the whole communication where everybody has to go through before actually being able to reach an attached node. So each node needs to know the IP address of that central node. Once it has that IP address, it's going to boot up, connect to the central hub, and the central hub is taking care of the encryption between node and hub, and further on between hub and node. All communication is then directed through that hub, and it is encrypted. And for anybody listening right now, we get around building ourselves a single point of failure by introducing a secondary hub. So we will always have a backup in case the central hub is failing. We just need our building automation system, right? So you want to have a backup. The good part is, by having that hub doing all the management between nodes, we now have no broadcast messages anymore. We run it like pretty much any other communication that is TCP in the usually Ethernet, internet, running through a switch, being directed, knowing the MAC address, and being encrypted. Let me just mention real quick, encryption of course needs a certificate authority. This might be the IT department of a building owner, or we are working on providing devices as well that might be able to provide the actual certificates, calculate them. It needs a lot of calculation power. I'm not going to bore you all about that, but there will be ways to give a certificate authority in a smaller network or in a bigger network. But we are now talking about the new addendum to the standard. What are we going to do about legacy products? What about our already existing buildings? Nobody wants to throw out well-working, good hardware. Not everything is going to support BACnet SC right out of the box, and especially not legacy products. They don't know the standard yet. So what are we going to do? Our suggestion is using a BACnet SC router. Basically, one bit more of hardware, being able to translate between the legacy products and the modern encrypted BACnet SC infrastructure. We are then looking at basically a mixed approach. We introduced then a completely secured network within the BACnet SC network, and tie any BACnet IP device directly to a BACnet SC device, BACnet SC router. You really have to take care not confusing everything with BACnet. Those BACnet SC routers will also have an MSTP port to finally get the serial networks secured and transmitted over a BACnet SC network. It's basically really just having some edge points. We have to decrypt some parts of the communication at some point to take along all the legacy devices. Let me introduce for that our BAS router SC. That's one of our new products. It's coming, as you can see, with 2 Ethernet ports, 2 MSTP ports, and pay attention to the 2 Ethernet ports actually. You want to keep BACnet IP and BACnet SC separate from each other. So you attach your BACnet IP device to one side and attach your BACnet SC side to the other port. You really want to have that physically divided from each other. The router will then take care of translating and decrypting, encrypting everything that is going through it. The BAS router SC will also be able to provide primary central hub functionality or secondary hub functionality, and even comes with the capability to be the certificate authority I mentioned for smaller applications or just for part of a building. Keep in mind that needs a lot of calculation power. So at some point, if you have a big building, you probably want to go for proper CA server. So let me just summarize everything I suggest. BACnet SC is now going to be an addendum to the protocol. We are going to talk about it like we are talking about MSTP and the IP right now. It's no rocket science at all, despite using TLS and encryption. That rocket science we leave to the IT department. We redirect communication through central hubs and introduce nodes. that are basically just clients that establish a secure connection to the app. And we can take along legacy products by introducing BACnet SC routers to the whole infrastructure, by giving legacy products the chance to actually getting encrypted and sending the messages through that router. Yeah, I guess that's it.